Alright, hello, welcome back to making a synthesizer in C. This is episode 5. So let's show what we've done so far. Let's run our synth. Oh, let me do build and run that. Here we go. So this is our synth. It's pretty cool. So today we're going to make a user interface for this so we can tweak the values. So yeah, and what else can we do with this? So we've got our different shapes and we can sort of mix them in different ways. So let's get started on that. So I don't want to get bogged down into making the GUI library. So I'm going to use one that already exists. We're going to use RayGUI. So let's go to that. So here it is, RayGUI, a simple and easy to use immediate mode GUI library. And I believe to use this, we just need a single header, raygui.h. And they also have some icons as well if we want to use those. So let's go ahead and do that. So where would that be? raygui.h and our icons.h. So let's copy that, put that into our include. And then we'll do our icons.h. All right. Now if we come to RayGUI, the header file, let's see what it says. Yep. Configuration. So we need to define RayGUI implementation. So we'll do that here. And then include raygui.h. And if we want to use those icons, we do define RayGUI support icons as well. Fantastic. So see if there are any examples. Were there any examples on the website here? Examples. So it does GUI load cell default. GUI grid, draw a fancy grid. Oh wow, that's a lot of code. Let's see if there's any simpler example. Lots of controls, test suite. So we're just going to have to mess around with this, I think, to get a feel for what we can do with this. Don't want this standalone one. All right, let's come back to this one. This one seems to make sense. So GUI load style default. Go to our synth. Go to our main, so we'll do this here. Let's just see how well this works with this draw style. And I'm going to build and run. Wow, okay, that's pretty cool. So drawing a grid, that could become useful. So let's see what else. We've got GUI and the auto selection tellers, all the different things we have. So really what we want is like a panel to the side of the screen, I'm thinking. GUI panel. So it just takes a rectangle. So this panel is going to be, say, 200 pixels wide, and then screen width so let's look at that. So we've got a panel. Does it not take a color? Or we could do a GUI color panel, in which case we take a color, which would be like, if we wanted a red panel, it would be 255, 255, 00. Then if this wants 4 numbers, yeah, it takes in alpha as well. I was not expecting. Oh, so this is a color selector. I guess how it works is in style. Let's have a look. GUI set style, it needs a control. Where are these controls defined? Is there like a enumerator? I think we need to come back and read a bit more about it to understand how to use this. Window box, group box, line panel comes with a default style. I see. So all the colours are actually set by a style. Interesting. Well now. Let's go for this jungle style. I like the jungle. So how do we import this? So I'm guessing we need to download this folder. Don't know if there's a way. It'd probably be easier if we just download everything. So we'll just download it. Open that. Let's open this in Explorer. Let's just copy this in here so we've got access to it. Rename this to just Ray-GUI. So I'm guessing we want Ray-GUI styles jungle. So let's have a look. I guess it'll be GUI load style, and then don't know if you just pass it the name of the folder. Let's have a look. Oh, we need to set this back to just GUI panel, and you just give it a rectangle. Did it say anything about trying to load a style? It does have a README. That doesn't tell you how to load it. So there is a file in there called jungle.rgs. There we go. Okay, great. So this is going to be where we have all the controls. This could probably be a bit wider. Might make this wider as well. Should be alright for now, actually. So we'll make this 350. See how that looks. There we go. And then we'll move this wave over. So say 350, like start, and then when we're drawing this line strip, we want to add panel like start to it. There we go. And the same with all these texts. So it's going to be panel like start, panel like start. Good. And then we don't need to draw that line here. We can get rid of that. So we'll get rid of that line entirely. And this grid spacing, let's set it to 80. Or what we want is a division of the screen height, maybe divided by 8. There we go. All right. So now we need to do the actual controls. I don't need that comment. It's obvious it's drawing a grid. How are we going to do this then? We want a button that adds an oscillator. Maybe a drop-down box that selects the shape. And then sliders to change the frequency and the amplitude, something like that. So let's try this. What we want is a GUI button. So that will have a rectangle and then text. This panel X start really should be X end, because X start would be 0. Panel Y start will be 0. It should be panel width, panel height, it's going to be screen width, so we'll do this, panel X start, panel Y start, panel width, and panel height. So in those places, this becomes panel width. So I'm going to have a rectangle that's going to be, where's this button going to be? It's going to be in the relative to the panel X start. We'll give it a bit of padding. Same. The width is going to be, I want it to be panel width minus, I think it has to be 20, and then we'll make it 50 wide, and it's going to say add oscillator, and this returns a bool, basically saying click add oscillator. So this is true if it's been clicked. We'll just printf. Now. Yep, you can see that coming out there. Nice. Probably can be like half the size. And then we're going to want another panel. So what happens if we layer another panel on top? Say plus 10, plus 50, minus 20, 100. Oh, that's cool. We just get the outline. All right. So this is we're just gonna mock up the first oscillator. So this is gonna be an oscillator user interface mockup. And again, constant, and I will call this panel X equals this. So this is panel X. It's going to be os panel Y. Os panel width. This is on the wrong line, and then this would be x dot minus 20. So then we're going to need, does it have like a slider? Slider control extended, returns selected value and has text. So again, that needs some sort of bounds. It needs what's text left and text right. We'll just put that here for now. Float value. Let's see. I guess it's a value from 0 to 1. Oh, it's a value from min value to max value. So our min value. So we had 440, and then our min value would be 0. And our max value would be R sample rate divided by 2. So now we just need to set the rectangle for this. So this is, again, it's going to be os panel x, os panel y. Width, it's going to be os panel width. And then it's going to be 25 in height. Let's give this a go. So I see. So this needs to be constant. I'll call this slider padding. We'll do 10 again. So this will be plus slider padding minus slider padding times 2. So this needs to be, I don't know, 30. Do we even want right? Oh, we use the same slider padding value. So this is frequency, isn't it? And if we just put in a float up here, call that temp frequency. So you pass in, and it gives us back what it's been changed to, I'm guessing. Obviously, it's still doing it over the mouse. While we're doing all this GUI stuff, like make it super quiet. Where are we going to draw the value? So I'm a fan for this. So this is going to be the frequency slider. Let's say slider control There's also slider bar. What's the difference? GUI progress bar. Let's see what the difference is with slider bar. Oh, I see. No, I think we just want the slider. And then I'm going to give this a bit more left padding. And then this will just display like the frequency. So this should be something like this, which means we need a bit more padding. And a bit more shifted to the right. Well, let's go to the maximum, which will be 20, something around 20,000. Again, we need to increase these numbers. Okay, I'm quite happy with that. So now we need to pass in this. So what would be the maximum number of characters? This is 10, let's do 16 to be safe. So what we do is we do char. It's going to be an array of, so I'm going to call this slider label. And then it's called sprintf. So unlike printf, which prints to the console, sprintf will sort of format and print it into a specific string. So this is literally just going to be percentage. So this is saying replace this with a float, but with only a precision of 1 decimal place. And we're going to do hertz. That's going to be the temp frequency. And then this would just be slider label, right? There you go. So now we can get rid of, where do we set the frequency? Here with the mouse position, we have the base frequency. So really this can go inside the synthesizer. We can have a float, base frequency, right? And then if we come back down to here, we don't even need these anymore. And then this would just be base frequency. We'll revisit it, seeing as we're already passing in the synthesizer object. Possibly we don't need to also pass in the base frequency. Well, we'll leave that for now. So here's our synth, and now we just need to change this to synth.base frequency. Once again, get rid of this temporary variable. Let's give this a go. So it doesn't change that, but now we got now the only thing is this is a linear scale, which means you know, we've got all this range here, which just sounds to us perceptually very high frequency, whereas you get most change in the lower frequencies. So really what we want is like a logarithmic scale. Which means this can't be just the base frequency. We need to do a logarithm, pass that in, and then do the inverse. I think. Let's do that. What we'll do is do a float, and we'll call this the log frequency, and that's going to be log 10 of the synth.base frequency, and we're going to pass that into the slider. So we'll pass the log 10 of that, and then we need to reassign it synth.base frequency, and then to get the inverse of that we need to do 10 to the power of, so that'll be 10 log frec. So this will come back here, and then so our min max range will still be from 0, but now it needs to also be log 10 of and half the sample rate. So if we give this a run, you can now see, yeah, we got a much more play in the lower range, and then it gets a much higher frequency pretty quickly towards the end. So that's a bit nicer. Let's put the cool. All right. So we got the frequency slider. We're going to want an amplitude slider. So again, let's just put this in here inside the synth. And then we'll come down here. Now the amplitude, again, you probably want it logarithmic. We could do decibels. Let me have a look at that. So let's have a research for like linear amplitude to decibels. The linear amplitude one is assigned to 0 dB, so that the maximum amplitude possible is 100 dB, and 0 dB is likely so yeah, because our perception of volume isn't linear, it's logarithmic. So decibel equals 20 log 10 of, what's A? It says A is the amplitude of the signal. Yeah, also our perception of the loudness of a signal will also depend on the shape of that, the waveform shape we use. So it might not necessarily make sense to use decibels in this case. But we can put in we might as well. So we'll call this log amp. Oh no, we'll call this dB, decibels. So 20 times log 10f of synth.base amplitude, right? And then we'll say decibels equals let's just copy all of this. We want this to be a bit further down, so plus 30. The label will be, so this is our frequency slider label, and this is going to be our amp slider label. So this will be dB, or is it dB? Yeah, it's lowercase d, uppercase b, I think. Yeah, so this will be decibels, and then we need to do the inverse of that. So synth.base amplitude will be PowerF 10 decibels. So we times it by 20. So we now need to divide it by 20. Possibly. Or to make this easier, I'll divide it by the reciprocal. I mean, multiply it by the reciprocal. So that all looks good. So now this would just be from 0 to 1. Actually, one way we can look at this is if we come to our graphing calculator, where x will be our amplitude. So right now the red line is our linear. From 0 to 1, 0 to 1. This is a linear scale, so we were doing 20 times log 10. Is there any way to get log 10 of x? So yeah, it starts at 1 and then goes down pretty rapidly to neg. Come back to that. Starts at 0, I mean. So this would be like 100 to 0, right? Why is this doing? Well, this needs to be, this actually needs to be decibels. Might not like the negative number. Let me just log these out. So we might have to, if it doesn't like, let's see if we can see the code for GUI slider, min value, max value. That should work all right with negative numbers. Let's, if we say make that 1. So we might have to do like plus 100, and then this would be from 0 to 100. But then when we actually display it, we'll do minus 100 here. And then the same here, when we're doing the power, we need to do minus 100. Let's make this a little longer. Why is it 1 dot? So what happens if we get rid of this times 20, then it... And then if we say this is, gotta give this, call this D. So what we want is 10 to the power of D times 1 over 20. Okay, so if we get rid of this 20 term, so yes, we can see that returns that to normal. So now if we do 20 times that, oh, so we need to do it in the power. Okay. Let's try that. So this would be decibels divided times 1f over 20. So we can, let's go back, see if this negative works. There we go, that's what I was looking for. So 0, negative 100. So now this box is to so that's 30, maybe 40. There we go. So now we can have this set the overall amplitude So when we're doing the handle audio stream, or maybe here, we can also times it by the synth bass amplitude. There we go. We probably don't want to go all the way to -100. Usually like -60, something like that will be more than enough. So we'll change the minimum -60 and get rid of this print. Oh, did I do -6? I meant to do -60. Cool. And then our bass amplitude should start at 1. Yeah, 1. Our bass frequency can start at 440. All right, now that we got that, what else? We're going to need a drop down box to select the shape. So that was our frequency slider. This is our amplitudes slider. Then we're going to need our shape select. So is there like a GUI drop down box? How is this meant to work? It takes in text, active, edit mode. Text split. Split controls text into multiple strings. How's it splitting it? Is it splitting it on a semicolon? Alright, let's do this. We'll paste in you. So you can be, let's try 70. Let's try this then. Sine, sawtooth, square, triangle, int active, which I guess is the active index. So we'll do the shape index equals 0 for now. Okay. What's edit mode? What? If edit mode, all this code, otherwise. Maybe that's like you can type in like a text editor, a text field, and then it returns a bool, returns mouse click. We'll ignore that for now. Oh, I see. So that edit mode is for state. So you would have like a bool. Is shape drop down open, starts off with false, and then you would do am I saying that false every no? Oh, so I need to make it like into a toggle? I see. And then if we put this up outside the loop of the program, there we go. Okay. Okay, so I think what we're going to need to do is create a new structure to hold information about the UI stuff. So I'm going to call this the UI oscillator. Which is then, it's just going to have a shape, a wave shape. So we're going to need an enumerator for that. Wave shape sign. I'm going to put in a none as well, just in case you want to. Sawtooth, square, and triangle. Define wave shape options. So this will be our named that. I'm going to move you up here, and then our synth is going to have I'm going to get rid of this base frequency. I'm going to have a bunch of UI oscillators. how many can we make? Say we could have a maximum of max UI oscillators. Again, we'll do 32. And then we need to do or I'll do so when we define the actual thing, we'll say by default there are 0. All right, let's start pulling out this to a function. So we're going to have a function called draw UI. It's going to take in our synth. And I'm going to pull all this out. Cut, and this will become draw UI. And we'll pass in a synth. We need to get some of those variables we were using. Put them in there. What else? What else? So now the frequency of each oscillator, we don't pass in this. We're not going to be setting the frequency like this. So we can get rid of this. Check it, sorry. And that's looking good. I'm going to set the amplitudes of all our oscillators to, let me just save this. But yeah, I'm going to say, copy this, comment it. They're all going to be 0 to begin with. So actually our UI oscillator count, we'll make that a define. We'll define up here UI panel width, make that 300. Then we can reuse this back down here. Will become UI panel width, UI panel width. Oh, we did 350, didn't we? 350. Right, we've still got some errors. So now we get to actually do the logic where we add an oscillator. So when we add an oscillator, we need to say, hey, synth dot UI oscillator count will increase by 1. And now all of this will go into a loop. So we need to say for size t, we'll call this UI osc I, as long as US is smaller than synth.ui oscillator count. Yep. So select all U, indent U. So now our panel X correct, panel Y, but this now needs to be plus UI osc. We need to lay them out by the index. So what's the height? We'll put the width and the height first, then we can refer to the height here. So if we've got multiple of these oscillator UIs, they should lay out in vertical order. We're going to get a pointer to call this UI osc. It's going to be a pointer to it, and that's going to equal synth.ui oscillator. And then this will be frequency. Right. This will be our amplitude. This becomes, what did we call that? Wave shape options. So our int shape index equals shape. We'll convert that to an integer. So sine was at position 1 because we had that none there, didn't we? So like this equals 0 and this equals 1. We'll make this just explicit. So we need to subtract 1 from this, so this is -1. And then we'll say UI or shape equals wave shape shape index +1. And this is drop down open. We'll go inside our UI oscillator as a wall is drop down open. So that will be UI osc is oh wait, no, we do want, what do we, yeah, sorry. And we'll do that. Let's see if this builds. We got a runtime access violation at synth 241. Why? GUI drop-down box. Did we use the wrong? Are we getting a problem with our shape? Oh, so it seems to be that the index is already 1 based. Huh, wasn't expecting that. So here we go, and we can add multiple oscillators now. Might add a little bit of extra padding. When we lay it out, maybe we'll say times plus an extra 5 pixels. So here we go, that's looking good. So we probably also want, at some point we want to make this a scroll, and also we need like a way to delete. And the way we would do that is another button. So we'd do full is delete button pressed equals GUI button rectangle we'll just say remove and this is going to be at 90 maybe. Let's just see. No, it needs to be 100. The only problem is it's drawing on top of the drop down. Ooh. We could put it at the top, or even if it was just an X, like if it was an X in the corner, like this. And then the width would just be something like 50. Could be here. In which case I'd put you at 70, and then I'll just do, see how this looks. Nope. Bit more. There we go. So then we say is delete button pressed, and if it is, we then need to remove it from the list. So there's a couple of ways we can do that. We can just swap its location with the last oscillator in the list. But then the problem with doing it that way is things will shuffle around, and that might not be the best user experience. I'll show you what I mean. So I could say synth UI oscillator UI osc I is equal to, I just swap it with the last one, which would be -1, and then we just decrease the count if I did this, works okay for one case, but if we add a couple, say we'll make this triangle, we'll make this, this drop down is going to be a problem. I'm not sure what the solution was. So if we set these to full, so and then I'll add another one, this will be sawtooth. So if I remove this one, you can see it just swapped it with the sawtooth one, which I would rather it would just collapse, which means we have to do like a bit of memory move, like it would be mem move. Does not say how, so it would be and then it would be however many. So what this is going to do is well, what I hope it does. So this would go, this would come here. So we have our, say we have our array of oscillators. I'm just going to label them like A, B, C, D. So before, what we were doing is we were just like swapping D with B to remove an item. This would happen, and then we would make the oscillator count one lower. We were doing minus equals 1. So now the array just becomes 3 elements. What I'm going to do instead, or at least what I hope this does, so I've put this back, ABCD is it's going to move this memory. So this is what these two lines are saying, starting at starting at the start of the array, jump I spaces. So say we're on B, it's going to jump to B, +1, so it's going to jump to the one after. And then this third line here says how long, the size of the memory you want to move. So we want 2 elements. So UI oscillator count is going to be 4 minus our current index, which is 2. So that's going to give us 2. And we're going to move it to where B is. So what's going to happen is we'll get A, C, D, D, and then we can subtract 1 from it, like this. That's my theory anyway. Let's see if that works. So A, B, C, D. I'll just like put these here to signify that. Yeah, that seems to be working fine. Oh, actually no. Triangle. I might have got the mem move thing wrong. The C library function memmove copies n characters from. Oh. So I need to. the number of bytes to be copied. So actually this needs to be size of times size of UI oscillator. I believe. So this is triangle, put these to the end, put these to the middle-ish, quarter. So if we do that, there we go. That's working as I expected. Cool. So now what we need to do is we need to map this data into our actual synth data. So how can we do that? So I'm just gonna, I mean, we could do it in the same loop, but I'm just gonna make another loop here, just in case, because I have a feeling we're gonna end up refactoring this code anyway. But I'm gonna get an oscillator, and then what we'll do is a switch statement. Say UI oscillator shape. And we'll do like case, wave shape sine. So if it's a sine wave shape, we need to there's num oscillators. Where does this get used? So we actually need to do 4 of these. Need to do num sine, num sawtooth, num triangle, and num square. And then by default, these will all be 0. We 0 them. Right. And then in our loop here, we're actually going to reset this each frame. So we'll say reset synth, and we'll say like the synth dot num sine is equal to 0. So here we can say if it's sine, we add 1, or rather we can say oscillator. We'll get a pointer to an oscillator which is equal to synth dot what did we call them? Sinos. Synth num sine like this, and we can say hey. Alright, I'm going to do this as an if else statement. If UI oscillator shape equals wave shape sine, Let me just see if this compiles, because so we need to pass in num oscillators into this function. Which means here we now need to pass in synth.num sine, synth.num sawtooth, this is the triangle, and synth.num square. Alright, so we've still got this error. Am I doing something dumb here? Synth. So it has to be addressed to. All right, I'll do it how I was doing it before then. Oh, I think I understand now. Because this is actually a pointer to a stack-based array. Yeah, which is why we need to take a pointer to it, address off. I mean, an alternative way to do this is to just say like this. Cool. So now we can repeat this for the other 4 shapes. So we'll do sawtooth, will be the sawtooth osc, sawtooth. The square will be the square osc, and that'll be num square. And finally, triangle will be triangle osc. And triangle, you don't have triangle. Why did I not capitalize that? So we're duplicating a lot of code here, this, and this. So what I can do is pull this out. And then we don't need to set this each time. And then we'll get this. We'll say if osc does not equal null, then we can do this, right? So let's give this a go. Right, so that isn't working. So we need to ask ourselves why? Why is it not working? So, right. So it's showing us the option for sine. And I think it's because, again, we've got this non here. Whereas if we had non, now it makes sense. All right, let's make this whole thing louder. Where is our master volume control? Here it is. Make it 10 times louder. And also I'm gonna, all right, clean you up. And then when we're drawing the signal points.y, I'm going to double this to 400. See if this works. All right. Let's add in a square wave. Cool. Now let's add in a triangle wave. What's that? 360. So let's do like 120-ish. Nice. And then if we set that back to none. So there we go, we've got a nice little UI there going for our synthesizer. So yeah, we'll definitely improve on this next time in episode 6. Alright, I shall see you later.